determinants. Our next concept is summation of determinants. So, if delta r, just the determinant is denoted with delta of r is equal to f1 of r, f2 of r, f3 of r. This means here this entry in terms of r, this entry also in terms of r, this entry also in term of r. Just this is the function in term of r. Function means we know actually function in x means some ax square plus bx plus c, ax cube plus bx square, or any one function in x. That means f1 of x, if you write, that means this expression in terms of x. If it is f1 of r, this expression in terms of r. And second row and third row all are different. Then this in this determinant only first row entries only depends upon r. So rest of these two rows doesn't depends upon r. This is the important thing we have to understand. Now if you want to do apply sigma notation, sigma, this is called sigma. Sigma notation means summation. Sigma r is equal to 1 to n delta of r. So sigma r is equal to 1 to n delta of r. R is going to 1 to n. This is the important here. So that means here r is in which term r is there, this sigma is affected to that term only. That is the important. See, because of here first row, second row, third row, out of these three rows only first row only depends upon r. So this sigma is applicable for only first row. So rest of the rows we have to write as it is. So that means first row entries are sigma r is equal to 1 to n f1 of r, sigma r is equal to 1 to n f2 of r, sigma r is equal to 1 to n f3 of r, and second row, third row write as it is. So based on this one, you take one problem. If delta r is equal to, so this is not sigma, if delta r is equal to r, 2r minus 1, 3r minus 1, first column entries, and second column entries are x, y, z, third column n into n plus 1 by 2, n square, n into 3n plus 1 by 2. So here for second column, third columns are not depends upon r. Okay, so then find sigma r is equal to 1 to n delta of r. So this sigma we have to apply for only first row, sorry, first column. Okay, so now sigma r is equal to n delta of r is nothing but first column entries. Sigma r is equal to 1 to n r, sigma r is equal to 1 to n 2r minus 1, sigma r is equal to 1 to n 3r minus 1, x, y, z. So say third column also write as it is. Now, so separately we are going to discussing about each entry in the first column. Sigma r is equal to 1 to n r. How it will be? Sigma means summation. First we have to substitute 1 here. After that substitute 2. That means 1 to n means only we have to use integers. First substitute 1, next substitute 2, next substitute 3, up to we have to substitute n, and you have to keep in between plus because it is a summation symbol. This is okay. So total becomes to 1 plus 2 plus 3 plus 4 plus up to n. This is equal to n into n plus 1 by 2. Next, second one, sigma r is equal to n 2r minus 1. Sigma r is equal to n 2r minus 1 is nothing but sigma is applicable for that means sigma you have to expand first terms. That means you can apply sigma to this term and this term also. So otherwise substitute directly r is equal to 1 to n in this expression. So 2 into r minus 1, that is 2 into 1 minus 1, 1. 2 into 2 minus 1, that is 3. 2 into 3 minus 1, that is 5. Like that, if you write 1 plus 3 plus 5 plus 7 plus up to, in the place of substitute here n, you get 2n minus 1. So, but you just understand this is up to 2n minus 1 means sum of here how many entries are there means here n entries are there. That means n terms are there. 1 plus 3 plus 5 plus 7 plus up to 2n minus 1 means here n terms are there. Okay, so n terms sum of first n odd natural numbers is equal to n square formula. Already I gave this formula. Okay, next one, sigma r is equal to n 3r minus 1. Substitute 3r minus 1 in the place of r. 1 2 3 up to n. 3 into 1 minus 1 2, 3 into 2 minus 1 5, 3 into 3 minus 1 8, up to, actually here you have to understand up to n terms are there. So nth term becomes to 3n minus 1. But here I written n. So here also up to we have to write 3n minus 1. Okay. So what you have? So 2 plus 5 plus 8 plus up to 3n minus 1. But you understand here up to n terms are there because 1 to n you are substituting. So total we get n terms. So understand here this is in AP 5 minus 2 3 8 minus so 5 minus 2 3 8 minus 5 3 like that. So common difference is same. So here sum of n terms are there. So which are in AP. So what is the formula? N by 2 into 2a plus n minus 1 into d. Okay, a total number of terms is equal to n are there. So we have to get n by 2 into 2 into a. 2 into a means first term 2, 2 2s are 4 plus n minus 1 into d. So n minus 1 into d means here 3. So 3n minus 3 we have to write here. So this is equal to n by 2 into 4 plus 3n minus 3 means 3n plus 1. So n into 3n plus 1 by 2. So now you substitute in this first column. So delta of r is equal to first one you have to here we have first one n into n plus 1 by 2, second entry n square, third entry n into 3n plus 1 by 2. So second column xyz, third column n into n plus 1 by 2, n square n into 3n plus 1 by 2. Once you check the columns, so here first column and third column all are identical. These two are identical. So if two columns or two rows are identical, then the determinant is equal to 0. So that's why this value becomes 2. So where it is, this value becomes to 0. Sigma r is equal to 1 and delta of r is equal to 0. Okay. So based on this one, we have one more question. You try this one. Actually, this one in terms of GP. Okay. So I am giving the just question. So you can understand. If you doesn't understand, you ask me in study hour. Okay. So this is the question how to do, so you complete this one. So that one proof also I am giving. So without seeing proof, once you try it, otherwise you follow the proof. Next one, derivative of the determinant. Derivative of the determinant. For suppose if f of x, how many rows are there? No problem. Okay, in each row how many entries are there? We don't want. Okay, for suppose you understand this is the first row. Just I am notation with r1 of x. R1 of x means in first row any number of elements, any number of entries we have. No problem. R1 of x, there that may be 3 entries, 2 entries, 4 entries, any number of entries. Same second row also just denote with r2 of x, any number of entries. Third row also any number of entries. Okay, so it is not a column. So just a row I am denoting with r1 of x. Second row I am denoting with r2 of x, like this. For suppose this is first row. This total I have denoted with r1 of x. This total I have denoted with r2 of x. This total I have denoted with r3 of x, like that. Okay, if you want to derivate, okay, if you want to derivate the determinant, see here. First of all, f dash of x means first we have to apply the derivation for every entry in the first row and write second row and third row as it is. Generally, derivative symbols we have to denote with r1 of x derivation it represents with r1 dash of x. This dash means derivative. Otherwise, you can write d by dx of r1 of x. You can write. So mostly CBA. That means IIT foundation students, they know very well derivative. So this year in first year we didn't complete derivatives, I think so. If you know, if you completed, so no problem, you can follow me. Otherwise, just to remember how to write the derivative. So generally r1 of x, r1 dash of x, this means derivative of r1 of x. That means first row with every entry we have to go for derivative. So how to derivative means in derivative topic we know very well. Otherwise, I will give small 2 or 3 formulas based on derivatives. We just follow them. Okay, to complete this topic. After that, after derivations, we can learn more formulas based on derivatives. So after that, so after first row derivation, so second row, third row, write as it is. Now first row, second, third row, write as it is. Now first row and third row write as it is and go for second row derivation. Plus first row, second row write as it is, go for third row derivation. If we have one more row, so go for procedure. First row, second row, third row write as it is and go for fourth row derivation. Okay, similarly whenever you have number of columns c1, c2, c3, there are three columns. So if you want derivative for this determinant, first we have to derivative for first column and second column, third column, write as it is. Plus go for first and third columns, write as it is, and go for second row, second column derivation. Next one plus first column, second column, write as it is, and go for third column derivation. Okay. Here I am giving some formulas of derivation. Actually, derivative symbol is d by dx of x power n. So, okay. Actually, here we have written dash. Actually, if you have f of x for this derivation, you can write as d by dx of f of x. We can write, or f dash of x. You can write anyone. You can write, no problem. Okay, so generally dash means derivation. So this derivation how to do, n into x power n minus 1. Remember, for suppose example, if we have x cube, d by dx of x cube is there, so that we gives 3 into x square. 3 minus 1 gives 2. N into x power n minus 1, that means 3x square. For suppose d by dx of x power 5, that means 5 into x power 5 minus 1 means 4. So next d by dx of constant, any constant, 1, 2, 3, 4, 5, root 3, 1 by 2, 1 by 5, whatever may be. For this derivative means how to write this one, d by dx of 1 into x power 0. For suppose if you take here 2 into x power 0, no problem. Okay, so this gives power means 0. So what you can write, 2 into 2 already is there. Okay, 0 into x power 0 minus 1, that means minus 1. 0 to anything is give 0, like that you just remember. So derivative of any constant is 0, just to remember. And just one more formula you just remember, d by dx of some a into x power n. For suppose multiplication is there, a into x power n. Okay, here a is the constant, so write a as it is the, and derivative for x power n, n into x power n minus 1. Okay, just to remember these formulas to complete some problems of determinants. After derivations completion, you can do more types of problems based on derivatives in the determinants. Okay, see here one concept you just remember, why you have to use derivatives means, if f of x is equal to ax cube plus bx square plus cx plus d, if you want to find out the value of d, that means f of x they are given, and this expression in terms of ax cube plus bx square plus cx plus d. If I want to find out the value of d, what should I have to do? By keeping x is equal to 0, this ax cube, this term becomes to 0, this term becomes to 0, this term becomes to 0, then we have only d. So this d becomes to f of 0. So like that expression whenever they given, if you want to find out the constant, so go for substitution x is equal to 0, then that constant value we may get. That here the constant value is nothing but f of 0. D is equal to f of 0. If I want to get the coefficient of x, that means c. If I want to find out the c, what I have to do means, see, just follow. F, go for derivation on both sides. F dash of x is equal to, see here, this is nothing but ax cube. Ax cube, how to write? A into 3 into x square. Okay, according to x power n formula, d by dx of x power n is equal to n into x power n minus 1. So ax cube means a into 3 into x square. For this one, b into 2 into x power 1. For this one, c into 1 you get, because of here x derivation means x power 1, nothing there means 1. So 1 into x power 1 minus 1. X power 1 minus 1 means x power 0. X power 0 means anything power 0 is 1 only. So you get to c into 1 into 1. That means you just remember here, d by dx of only x is equal to 1. Okay, so this value becomes to only c, and constant always 0. Here d is the constant. So we have only a into 3 into x square plus b into 2 into x plus c. After derivation, if you keep x is equal to 0 in this entire equation, then you get only the value of c. So this term becomes to 0, this term becomes to 0. Therefore C is equal to f dash of 0. To find the constant, we have to go for derivation. Okay, for the to find the, that means coefficient of C, the coefficient of x. Okay, that means C value. So go for derivation and keep x is equal to 0. So C is equal to f dash of 0. So based on this one, you take one question. Here f of x is nothing but a determinant they given. F of x is nothing but determinant. X square plus 1, x plus 2, 2, 2x square minus 1, x minus 1, 1, 3x square plus x, 4x minus 1, 1 is equal to x cube plus bx square plus, this is cx plus d. Okay, then the value of d comma c comma a. So here a is the highest degree coefficient, here c is the coefficient of x, d is the constant. Okay, so I will explain how to do a because I didn't explain the highest degree coefficient. Okay, I will explain later. First you find out d comma c how to do. So to get the d value, so take x is equal to 0. Okay, then you get directly d value. That means d is nothing but f of 0. That means in this determinant, in every place of x we have to substitute 0. So d is equal to f of 0. F of 0 is nothing but 0 square plus 1, 1, 0 plus 2, 2, this is 2. Next 2 into 0 square minus 1, minus 1, 0 minus 1, minus 1, 1. 3x square plus x means total 0 plus 0, 0. This is 4 into 0 minus 1 minus 1. This is 1. So this determinant, if you expand it, you may get the value of 4. That is the answer for this question. Expand this determinant, you get 4. Next, to find a c value, go for first differentiation of f of x. This is the determinant. If it is only f of x, just you write f dash of x. But in the place of x, they given this is the determinant. So go for the differentiation for this determinant. That means according to row or column, you can go here. According to row or column, you can go. If you want to go to row wise, first we have to go for first row for differentiation, and second row, third row write as it is, plus first row, third row write as it is, and second row go for differentiation, plus first, second row write as it is, and third row go for differentiation. Okay, now otherwise column means go for first column differentiation, these two columns write as it is, and second column go for differentiation, these two write as it is, third column go for differentiation, these two write as it is. Okay, now I am going to do first row wise. First row I am going to differentiation. That means x square differentiation 2x plus 1. 1 is the constant, that is 0. X plus 2 differentiation, x differentiation is 1 and constant difference is 0. And constant is always 0. So we have only 2x 1 0. 2x 1 0 and write second row and third row write as it is. Plus. Now first row write as it is and third row write as it is. Go for a second row differentiation. 2 into x square means differentiation 2 into x. So 2 into x means 4x. Next x differentiation is 1 minus 1 differentiation is 0. So only 1. This differentiation is 0. And write third row as it is. Now go for third row differentiation and first row second row write as it is. So this differentiation is 3 into x square, that means 3 into 2 into x, that is 6x, plus x differentiation is 1. Here 4 into x differentiation is 4 and constant differentiation is 0. So we get only 4. 1 differentiation is 0. So this is the values. Okay. Now to get the value of c, take f dash of take x is equal to 0. That means c is equal to f dash of 0. So c is equal to nothing but f dash of 0. That means in this three determinants, substitute x is equal to 0. So here x is equal to 0 means 0 1 0. This is 0 minus 1 minus 1 0 minus 1 minus 1 1. So this is 0 4 into 0 minus 1, that is minus 1 1. So we get this one. Similarly, take x is equal to 0 in the second determinant. You get 1 2 2 0 minus 1. This is see here, this is I think so minus 1 it is. It is x minus 1. Okay, once to correct it. Okay, so this is 0 minus 1 0. This is total 0. This is minus 1 1. Now substitute x is equal to 0 in this determinant. 1 2 2. Next here minus 1 minus 1 minus 1 minus 1. Actually here in the third time differentiation only we have to apply differentiation for third row. Second row we should write as it is. So you get here, I think so, this is also 1. Okay, same this one. Now come to the point. So this is 4. Okay, now expand this determinant. This determinant actually according to this row plus minus plus, so you get minus 1 into, leave the row and column, this is minus 1 into 1, minus 1 minus 0. So minus 1 into minus 1 plus 1 you may get for this determinant here, plus 1. So maybe this is the for this one. Next, if you expand through this uh, column, because of these two are zeros, so plus 1 into, leave the row and column, what you have, minus 1 into 1, that is minus 1 minus 0. So minus 1, this minus 1 is for this one. Okay, remember, so this 1 is for this determinant, this minus 1 is for this determinant, and expand this determinant, so you get 6. Once you simplify, you get the value of this determinant is equal to 6. So minus 1 plus 1 plus 6, that is equal to 6. Now we have to go for find the value of a. This is highest degree coefficient. How to find highest degree coefficient means, so entire equation divide with the highest degree what you have here. Highest degree what you have here, x cube. So entire equation divide with x cube. Okay, that means procedure once you see here, procedure for finding coefficient of highest term. If x cube, then divide LHS and RHS with x cube. If x power 5, then divide with x power 5 both equation. And you just follow this logic. 1 by 0 means infinite, but 1 by infinite tends to 0. 2 by 0 infinite, 3 by 0 infinite, 4 by 0 infinite, 5 by 0 infinite, anything by 0 is infinite. But anything by infinite becomes to 0 always. Anything by infinite, 1 by infinite, 2 by infinite, 3 by infinite, you just remember this formula. Okay, so based on this one, so here in this given problem, the highest degree coefficient, highest degree is x cube. So go for entire equation divided with x cube. So if you divide with x cube, what you have here, x cube, x square by x cube means 1 by x plus 1 by x cube. X square by x cube means 1 by x plus 1 by x cube. Here one thing you have to do, here x cube is there. So this x cube, RHS, entire equation you can divide, no problem. See, once you clarification, ax cube plus bx square plus cx plus d, ax cube by x cube a, bx square by x cube b by x, cx by x cube c by x square plus d by x cube. You get RHS. But LHS means, in the actually if you want to divide with x cube means 1 by x cube. Already in the determinant, if you x cube, if you divide with the first row or first column, so we cannot divide with the second but for suppose if you divide this entire column with x cube, then no more x for this column or this column. That's why we just use the common sense. Here first column if you apply, x square is the highest degree, second column x is the highest degree, third column no more x. That means this x cube, here x cube is there, this x cube you can write as x square into x. So that x square into x, for first x square just divide with the first column, second x divide with the second column, and no more x here, so don't divide with x for this one. So it is very easy to divide first column with x square. X square if you divide with x square, so 1 plus 1 by x square. This is 2 minus 1 by x square. Next, this is 3 plus 1 by x. Second column if you divide with x, 1 plus 2 by x, 1 minus 1 by x, 4 minus 1 by x. So 2, 1, 1 as it is. That is the simplification here. Now, as x tends to infinite, anything by that means as x tends to infinite, if you keep here x tends to infinite, infinite square also infinite. Okay, 1 by infinite, this is 2 by infinite, 1 by infinite, 1 by infinite, 1 by infinite, 1 by infinite, all these becomes to 0 because of already give the formula as anything by infinite becomes to 0. So This is also b by infinite, c by infinite, d by infinite. All these are also zeros. So then you get only a. Okay, a is equal to, after keeping 1 by x square as 0, 1 by x square as 0, 2 by x 0, 1 by x 0, 1 by x 0, 1 by x 0. So we have the numericals. If we expand the determinant, then you get the value of a. Did you understand? So what you have to do to find the highest degree coefficient? First, entire equation divide with the x cube, and just use the common sense when dividing determinant. So segregate the x cube, just you write as the product how you want to use, okay, according to the given columns or rows. Okay, after division, so take x tends to infinite, x tends to infinite, as x tends to infinite, anything by x becomes to 0 only. Okay, so then we have, this is 1 2 3 1 1 4 2 1 1 is equal to a, because these three terms are zeros. Okay, now you simplify. So a is equal to this determinant you have. If you expand this determinant, you get the value 8. You know how to simplify.